Today's lesson is on inequalities in two triangles, and we get into indirect proofs. Now, inequalities within two triangles is called specifically the hinge theorem. And what we need to use this is we either need a side angle side look, right? We've got two sides congruent, and then the only difference is the angles between the two are different. And that's kind of why they call it the hinge theorem. It's like if you have a door and the opening are the same congruent size, but based on how far you open it, angle-wise, your opening between the kind of non-hinge part of the opening and the tip of the door is either larger or smaller based on your angle. So in this case, right, we've got side angle side, because 88 is bigger than 35, the opening across from 88 must be greater than the opening across from 35. Right? If you've got the sides in place and the angles sandwiched between them, you can do that. The converse of this is if we have three sides, but the third side is different. We have side 12 and side 9. Well, because 12 is bigger than 9, the opening angle across from 12, so angle C, must be greater than the angle across from 9, which is angle F. So what do problems look like for this? They're commonly going to look like this, or maybe even pretty commonly reflexive. Given that ST and PR are congruent, how does angle PST compare to SPR? So we've got side, now we're looking at these angles. And 24 is bigger than 23, so angle TSP, angle PST is going to be greater than, because it belongs to the 24, the SPR angle, right? Because the 24 belongs to that one, right? It's opposite of that one. And the 23 belongs to the SPR, like where that associates. Next one, how does AD compare to BC? Now this time we got, and side angle side look again, right? And this time 41 is larger than 39. So BC is larger than AD. Or, you can say it that way, or AD is smaller than BC. Right? Because how do they compare? AD is smaller, BC is larger. Either way works. If PR is equal to PS and QPR is larger than QPS, which is longer. And again, we're going to use this diagram a couple times for different things. So for this one, I'll label it, but then I can erase for the next one. So they're saying, right, we've got side, and this one's saying this angle is larger. That angle is bigger than that one, which is longer, SQ or RQ. So this one's bigger, right? RQ is bigger than SQ. So in this case, the answer is RQ is longer. Right? And again, I usually like to match it up right here. Like what's opposite, RQ greater than SQ, so RQ is larger. Next, switching it around this time, they said, what about if RQ is smaller than SQ, so this one's larger, so I can whatever, pick numbers, 11 bigger than 10, which is larger, which angle, right? Well, 11 bigger than 10, right? Rewriting it in the way I like it. SQ greater than RQ, therefore angle opposite SQ, so SPQ can be greater than RPQ. So which is larger? SPQ. So these questions are pretty short and easy to understand. Moving on to the indirect proof. Indirect proofs are called this because we are proving them indirectly. Why would we do that? Generally, you do proofs indirectly when that is either an easier way to do it or the only way to do it. And seeing, like, look at our given and our proof here for a second on this first page. They do not look like typical given or proofs, right? The given is something does not equal something. Well, that doesn't really help us. The proof is also something does not equal something. Commonly, we will see things like that or inequality. No, this greater than that. Well, we don't really have always an easy way to prove that. So how we have to prove is that we assume temporarily that the conclusion or the proof is false, right? We contradict the proof, meaning we do a TA, right? So temporary assumption, and abbreviations TA. So again, in this case, temporary assumption, if it's x not equal 3, something opposite of that would be x is 3. And then what we do is we kind of work backwards to try to contradict something. Because if this given and proof are true, if we contradict the proof, there should be some sort of impossibility, or sorry, if we temporarily assume that the proof is false, we'll run into something that's an impossibility, therefore a contradiction. So in this case, x equals 3 was our temporary assumption. Now we're going to try to build 3x plus 7. So then 3 times x is 9, and now add 7 to both sides. 3x plus 7 is 16. So again, our steps would be we multiply POE, we added, right? And now we got 3x plus 7 equals 16 after our given was 3x plus 7 cannot equal 16. There's our contradiction, which will sometimes do with a straight line with like an x in the middle. And then they'll restate the proof correctly. X cannot equal 3. Why? That was a contradiction. Some teachers like to put the steps of where the contradictions are. I am fine with not listing them just because most commonly it will be your second to last step and your first. Other times it will be things that aren't clear, like, oh, the definition of triangle broke, and we didn't use the definition of triangle, so there wasn't like a step to say where that contradiction happened. Next one, what is a temporary assumption? So again, temporary assumption practice here is reminding that we look and we flip this, right? So if we're proving that our temporary assumption, which we will abbreviate TA, is 3x minus 5 does equal 10, right? That's the flip of 3x minus 5 not equal 10. And that's it. And we're building this in for lesson 5.6b, where in 5.6b we will be working on a lot more proofs by contradiction, and even have a worksheet over that. Next, prove by contradiction that a triangle can have at most one right angle. So again, our if-then statement to think about would be if a polygon is a triangle, then it has at most one right angle, which this means less than or equal to 1, right? So our temporary assumption is triangle, pick a triangle, ABC, has greater than or equal to one right angle, would be the flip. We'll actually say greater than one right angle. Or you can even pick a number, like say 2. It's got 2 right angles, this triangle. Okay. Now this is where I would tend to generally go. Just like pick a number that works that's not less than or equal to 1. And then let's see how it breaks it. So as a reminder, triangle has to add equal 180. So these 3 angles add 180. And we're going to say specifically that angle A and B are right angles is our contradiction. Right? It doesn't help saying there were 2 right angles, but we don't know which ones they are. So again, reminder, that means those angles are 90 degrees by definition of right angle, and we're going to plug them into this equation and see what happens with C. So A was 90, so is B, and C still exists. Solving for angle C, we subtract 180 from both sides, and we get 0. Can a triangle have 2 right angles and a third angle of 0? Right, there's our contradiction. Triangle, by definition, and any polygon have to have positive non-zero angles. So therefore, if it's a triangle, it has at most one right angle. That was kind of our proof. Right, basically go back to that if-then statement and say it's true, right? Yep, triangles have at most one right angle. We've got a couple more algebraic examples, and then we'll get into some triangle ones. Prove by contradiction that 5x minus 2 is greater than 28, and x cannot equal 6. So go ahead, write your temporary assumption, and then mathematically finish it. So go ahead, try that one on your own. And here's how it looks completed. And I did want to bring up a point because we're doing some of these algebraic ones, but generally in the two-column proofs, right, your first step is still given. Once you recognize it's going to be by contradiction, or it tells you prove indirectly, the second step, reason is TA, and then you flip your proof, right? Negate whatever your proof is. So in this case, x not equal to 6 became x is 6. 5 times x gave us 30. 5 times x minus 2 gives 28. There's our contradiction. It must be greater than 28. And so our contradiction, we would then say x cannot equal 6 as our last step. Given AB is not parallel to CD, AB congruent to CD, and triangle ABC not congruent to triangle CDA. Now this just gives you a little peek into the geometry version of these proofs. Notice we have things that we haven't seen before, such as non-congruent symbols in both our prove and our given, right? So it's not really a way to prove this directly, right? These aren't proofs that we're just going out of our way to add steps to. You cannot prove this directly, right? So you can clearly tell that our contradiction is going to lead to contradicting, or you're going to learn the pattern that generally something in the given doesn't look right. That's what we're going to contradict. So in this proof, we've got given. Second step is going to be TA, and then we'll generally let you know, let's say proof by contradiction or prove indirectly. So it won't be a guess that you have to figure out. It'll be given to you that you need to do indirect proof. Now, this one actually does have information given that's useful. A, B, and CD are congruent. Great. Now, prove triangle ABC congruent to triangle CDA is our temporary assumption, right? We're taking that negation sign off. And so we have to look at how is that going to be leading us to a contradiction, right? So we're looking for what's going to give us something that will be parallel. So I'm going to take these angles here are going to be congruent. If those triangles are congruent, I can call them 1 and 2, or I can kind of use my letters. BCA will be congruent to BAC. And again, notice you can say that based on this order here. And that would have been a triangles congruent. So it's kind of weird to start with this step because we temporarily assume triangles congruent, CPC, and those are alternate interior angles that are congruent. So by the converse, the lines must be parallel. So AB must be parallel to CD, but that's a complete contradiction to what the given is. So there's our contradiction. And once you hit a contradiction, your next step is contradiction for a reason, and your statement is opposite of you're going to restate the proof. So like always, we end with our proof. Triangle ABC not congruent to triangle CDA. And that wraps that one up. That wraps up lesson 5.6a, and 5.6b we will do more proof by contradiction, including a worksheet. As always, let me know if you have questions.